It's my great pleasure to give this talk in the first international conference on fuzzy sets and their applications. I would like to express my thanks to the organizers to invite me to give this talk. Today,
we will see this outline. First of all, I will introduce some concepts about computing with words and its importance in decision making. Then I will focus in some challenges, mainly in enriched vocabulary in computing with words. And finally, I will conclude with some conclusions. So when we talk about computing with words, we should be aware that computing with words is a methodology that tries to emulate some capabilities for human beings, mainly two of them: the capability to converse, communicate, reason, and make decisions in an environment of imprecision and uncertainty. And the second capability is to perform a wide variety of physical and mental tasks without any measures. That means, for instance, when you are driving a car in a narrow road, you don't think I am 5 centimeters from the left and 10 centimeters from the right, and then I have to move 2.5 centimeters left to right. You say, I am closer to the right than to the left, so I have to move a little bit to the left. So this is the idea of computing with words, because human beings in their activities mostly employ words in computing and reasoning processes, and they try to obtain outcomes that are expressed linguistically from linguistic premises. So computing with words aims to achieve human-level machine intelligence, and to do that is necessary to be able to emulate the previous capabilities of human beings. So we can say that computing with words is a methodology in which words are used in place of numbers for computing and reasoning. The main foundations of computing with words comes from fuzzy logic. So, although computing with words was introduced at the end of the 20th century, their roots were presented in the 70s. The main idea of computing with words is to develop a computational theory in which the input are linguistic information that should be translated into an operational model language in which we make the computations, and then the results are expressed in a linguistic way. So, what I want to point out is that computing with words is a methodology that can be used for reasoning, computing, and mainly decision making with information described in natural language. So why computing with words is so important in decision making? Mainly because computing with words narrow the differences between human reasoning and computing. So facilitates the manipulation of imprecise vagueness in human decision making processes. And in such a way, computing with words can enrich the decision models, making them more precise and reliable. Initial works in computing with words try to provide a model that has been used across the time and still is used, that try to focus on how to manage the process for linguistic inputs to linguistic outputs. The linguistic outputs should be translated into a manipulable language in which we will make the different computations, and the results will be translated into linguistic information. Here is where the fuzzy stuff is key to obtain such results. So to deal with words in fuzzy linguistic approaches, there has been developed different computational models. Semantics models that deal with the membership functions, type 1 or type 2 membership functions. The results are also fuzzy membership functions that are more difficult to understand, and they need some kind of approximation to obtain a result. Later on, different computational models based on symbolic approaches have been developed that deal with the indexes and order of the linguistic information, and some extended models like the linguistic tuple have been widely used in decision making. What are the main challenges of computing with words in decision making? There are different of them, like how to manage the different meaning of the words in a environment, or how to increase the vocabulary to deal with linguistic information in decision making. Also, we need sometimes in decision making to deal with different types of uncertainty in the linguistic preferences. So I will focus in this short talk in how to enrich the vocabulary, mainly in computing with words applied to decision making. Most of the linguistic inputs are expressed by means of atomic terms. So this is sometimes quite limited, and we need to provide to disperse more elaborated information when they express their preferences. We need to develop some composite linguistic terms. So in the literature, there were some approaches try to deal with this problem. That approaches were studied in the latest paper, in the bottom paper in the slide, in which we found some limitations, like most of the models are far from human beings' cognition, they are fixed a priori, and they cannot deal with hesitant situations. So we try to overcome these problems and try to develop linguistic expressions that enrich the vocabulary of computing with words in decision making with a model close to human beings, flexible, and able to deal with hesitant situations. So that means that the experts, when they have to provide their preferences, sometimes they cannot fix just one preference, high, low, rather than they doubt, hesitate among different terms. So to deal with this, we propose the hesitant fuzzy linguistic term sets, in which the preferences can be provided by several linguistic terms, like very low, low, and medium. But what happened? This is not the way that the people, usually the human beings, elicit their information. So we provide a way to elicit this information by means of linguistic expressions by using context-free grammars. We propose a simple context-free grammar able to deal with this kind of linguistic expressions: lower than, greater than, at least, at most, and between. So these kind of expressions are common in decision making and are closer to human beings. So the main issue to deal with this expression is how to translate into a manipulable language. So we transform these expressions into hesitant fuzzy linguistic term sets, and from these linguistic term sets we need to compute with them. So we propose to transform the hesitant fuzzy linguistic term set into a fuzzy membership function that represents their semantics by means of computing a fuzzy envelope. According to the different expressions, we will obtain different kind of fuzzy membership functions. Although this idea has been widely used, still there are some challenges, but I would like to conclude this short talk pointing out that computing with words is a really useful tool for decision-making processes, because support the management of uncertainty in this kind of problems and try to bring closer the human being's capabilities and machine processes. Of course, there are still some challenges in computing with words for decision making. Try to obtain better semantic representation for the preferences, increase the vocabularies, and try to deal with multiple types of uncertainties. We have focused today in richer vocabulary.